Hello everyone, I am JP Rojas.
Hi, my name is Aniel Medenilla.
I am Geremy Wayne.
And I am Joseph Sullivan, and we are from St. Mark, grade 11, and the presenters for today.
So we are going to discuss three topics from basic calculus, which are instantaneous rate of change, optimization problems, and related rates, and we are going to give one problem for each topic for further understanding. So the first chapter we are going to discuss is instantaneous rate of change.
The instantaneous rate of change is the rate of change in any particular instant. That being said, it is the same as the change in the derivative at a specific point. For example, if we were given a function of f of x equals to x cubed, and the question asks, what is the instantaneous rate of change at x equals 3? The instantaneous rate of change is simply f prime of x, or in this example, f prime of 3. Now, we just simply need to determine what is our first derivative and calculate its value when x is equals to 3. To solve the equation, we first have to find f prime of x using the power rule. We determine that it is f prime of x is equals to 3x squared. We get this value by first taking the power 2 and multiplying it by the expression 3, and then reducing its power by 1. With that in mind, we know that the instantaneous rate of change at x equals 3 is f prime of 3 equals 3 times 3 squared, which equals to 27.
For our second topic, we have optimization rates. To be able to solve the problems, we need to understand the meaning of optimization rates, how to use it, and besides that, we need to learn when it can be used in specific situations. Optimization, it is the process of finding the most efficient way of accomplishing a task that involves finding the maximum and minimum value of some function. For instance, finding the least amount of distance to reduce the time spent traveling between 2 points. Finding the least amount of cost to build a doghouse, finding the maximum amount of power generated by phone, and so on. In summary, optimization is finding the minimum or maximum amount or optimizing to find the best or most effective use of a situation, opportunity, or resource. In real-life occasions or problems, it imposes some constraint on the values of x. Constraints are logical conditions that a solution to an optimization problem must satisfy. They reflect real-world limits such as protection rates, costs, budgets, and etc. The goal of optimization is to find the situation where you can achieve optimal condition to get the best results. In order to solve these types of problems, you need to be able to identify the maximum and minimum values of a function. There are two characteristics of these points in a graph, at the maximum and minimum value. The slope of the horizontal tangent line is 0, so in order to find the location of the maximum or minimum is to take the first derivative of the function. Set it equal to 0 and solve for x. We may realize this as we go further as we solve some problem. To solve the problem, we are going to follow these 3 steps in order to find the answer that we are looking for and to keep it simple. Step 1. Get 2 equations. Then step 2. Plug one equation to the other to simplify. Then step 3. Take the derivative of the new equation and set it equal to 0 and solve. Now that we know the steps required, let's proceed with our problem number 1. Example, the product is 192 and the sum is a minimum. Step 1. Get 2 equations. We must first analyze the statement to be able to form 2 equations. The product is the total or the result when variables are multiplied together. Simply, when 2 numbers are multiplied, it forms a product. Therefore, x times y is equals to 192. So that is our first equation. And the sum is when 2 numbers are added. And we can read the sum as the minimum, so therefore, x plus y is equals to m, where m is the minimum. Step 2. Plug one equation to the other to simplify. In order to find which equation you are going to plug to the other equation, we must find which we are going to optimize. The definition of optimization is finding the minimum and maximum of a number. So therefore, the statement that have the keywords minimum and maximum will be the equation where we will plug one equation to it. Therefore, x times y is equals to 192 will be our equation that we will plug into the equation x plus y equals m. In order to put the equation, we must solve for x or y of the equation for it to work. So let us solve for x. Transpose y to the other side, so therefore, our value of x is x equals 192 over y. Thus, we have one x value and one equation. These are x equals 192 over y and x plus y equals m. And then plug the value of the x to the equation. Therefore, our answer in step 2 is 192 over y plus y equals m. Now we are done with step 2. Let's proceed to step 3. Take the derivative of the new equation and set it equal to 0 and solve. Simplify the equation 192 over y plus y equals m. And we will get m equals 192y raised to negative 1 plus y. Then we are now able to take the derivative and we get the derivative of m with respect to x is equals to negative 192 raised to negative 2 plus 1. Set it equal to 0 and solve, so it will become negative 192 over y squared plus 1 equals 0. Then transpose 1 to the other side, then cross multiply. So first, we will get negative 192 over y squared equals negative 1, then cross multiply it, then we will get 192 equals y squared. Then square both sides to get the answer. Y is equals to positive negative square root of 192. Then recall our equation that we obtained in step 2 and substitute the values obtained in step 3. And we got y is equals to positive negative square root of 192 and x is equals to 192 over y. Therefore, if y is equals to positive square root of 192, then x is equals to 192 over square root of 192. If y is equals to negative square root of 192, then x is equals to 192 over negative square root of 192. This is the answer because we substituted the values of y that we obtained to the equation we found on step 2, and that is x is equals to 192 over y, and y is equals to positive negative square root of 192. For our last topic, we have related rates. So what is related rates? Related rates problems are applied problems in which we determine the rate of change of one quantity by relating it to other quantities whose rate are known. Related rates problems are word problems in which we use information about the rate of change of another variable to reason about the rate of change of a quantity. For example, the side length of a square increases at a rate of 2 inches per second. How fast is the area and the perimeter of a square changing when the side length is 6 inches? Since we are working with a square and the square has 4 equal sides, that means that all sides are x.
Now, we are going to find the area and the perimeter of a square. So, the equation of the area is length times width, or simply a equals x squared, and the perimeter is the sum of 4 sides of a square, or simply p equals 4x. Now we know that x is equals to 6 inches, and we have the rate in which the side length is increasing. That means that dx over dt is positive 2, since it is both given in the problem.
So the first step we are going to do is to find the derivative of a with respect to t. So if a is equal to x squared, derivative of a with respect to t is the derivative of x squared, which is 2x times derivative of x with respect to t. So it is gonna be 2 times 6 inches times 2 inches per second, which will be positive 24 inches squared per second. So the final answer for derivative of a with respect to t is 24 inches squared per second.
For the next step, we are going to find the derivative of p with respect to t. So if p is equals to 4x, the derivative of p with respect to t is the derivative of 4x, which is 4 times the derivative of x with respect to t. So it is gonna be 2 inches per second, which will be 8 inches per second. So the final answer for the derivative of p with respect to t is 8 inches per second. Since the side length is increasing at 2 inches per second, the square is getting bigger, which means that the area is gonna increase and the perimeter is gonna increase. So as we can see, the derivative of a with respect to t is positive, and the derivative of p with respect to t is also positive.